Before starting any test, it is a very good idea to have some sort of an expectation about the question, how many questions there are, what type of questions there would be, and what would be the mark. There would be around 7 to 8 questions in the S1 exam, and the questions would be about certain topics, and every paper has these questions. One of the topic would be data summary. So data summary would have questions about mean, mode, median, quartiles, and you might have to draw a box plot, and it might be given in the form of grouped data, or it can be given in stem leaf diagram. It can be in the form of a histogram. So that is one type of question. The second question is correlation and regression. So we can have correlation and regression. There can be two questions, one correlation, one regression, or there can be one question with correlation and regression both. In correlation regression, we have to calculate, and we might have to do scatter diagram, and we often have to interpret the question. Then the other part is the statistics portion. After the statistics portion, we have the probability portions, and the probability question, there would be one concept question about basic probability. So basic probability deals with tree diagrams or three set Venn diagrams, or it could be about a story sum or a die throwing sum. So it's very difficult to pinpoint what the basic probability question would be, but there are a variety of options that we can have. Then we have a question regarding random variables. So the random variables questions would be, we will be given a probability distribution table. It would be discrete probability distribution table, and we have to find the probability and expected value and variance. That's quite common. And finally, we can expect a question that deals with the normal distribution. So the normal distribution is a question where it's a continuous random variable, and we have to find the probability, or we might have to find the random variable itself. So that's the setup. So you should have an expectation about the entire question paper. The first question deals with correlation. Now, one thing is very, very important to remember. Read the question. It is very important that you understand the question, you read the question, and the question makes sense, what is going on. A medical research is studying the relationship between age, so studying the relationship between age and volume of blood pumped by each contraction of the heart. So there is a relationship between age and volume of the blood pumped. So age is X, and the volume of the blood pumped by the heart is Y, milliliter. So the researcher obtained the following data from a random sample of 8 patients. We have 8 patients. So this is 1, 2, 3, 4, 5, 6, 7, 8. And each of the patient, we took the age of the patient, and we took the amount of volume that the blood is pumped from the heart. And we have these information already done for us. The summation, if we add up all the values of X, we'll get this summation of X, then we have sum of X, summation of Y, and on and on. We have all the information given. So the first thing that we have to do, we have to calculate sum of Y. So now remember the formula for sum of Y. Sum of Y is equals to summation of Y squared minus summation of Y whole squared divided by n. That is the formula for sum of Y. Remember, there is a difference between sum of Y and summation of Y, and there is a difference between summation of Y squared and summation of Y whole squared. So let's put down the values. The first of all, we know the values of summation of Y whole squared. It is 39418. 39418. And we also know the value of summation of Y. Summation of Y is 560. And we have to do whole square of that, and there are altogether 8 data, so we have to calculate this. So this is going to be 39418 minus 560 whole squared, so this is going to be whole squared, divided by 8. So the value we get is 218. Question number B is calculate the product moment correlation coefficient. For short, it means correlation. That's what it means. So the symbol for correlation is R. So question number B is correlation equals to, this is the formula, sum of xy divided by square root of sum of x multiplied by sum of y. Now, in order to calculate this, we need some values, and the values are already given. If you check here, the sum of xy is minus 710, square root of sum of x is 2587.5 times sum of y is going to be 218. So this is the value of the correlation. So let's calculate what it is. So first of all, let's do what is downstairs. So 2587.5 multiplied by 218, and if we do square root of that, and it turns out to be 751, and let's divide. So minus 710 divided by the answer that we just got, and it is minus 0.9453. Now, one thing is important. Correlation has to be between -1 to 1. Correlation is basically the relationship between two data. We want to know whether they're directly proportional or inversely proportional. That's it. If the correlation value is positive, it means they're directly proportional. Or if it is negative, as it is in this case, it means they're inversely proportional. That means the relationship is opposite. So it means if age is more, if a person is older, then the volume of blood would be lower. So that's what it means. Inverse. Directly proportional means if one increases, the other would increase. Inversely proportional means if one increases, the other would decrease. Now, almost always, you have to write down some sort of an interpretation, some sort of an explanation of what is going on. And this is very, very important that you understand this. This itself tells you whether you understand statistical concept or not. Interpret your value of the correlation coefficient. So you have to interpret. So there is a rule for this. The first thing you write what type of correlation it is. So you write whether it is positive or negative, and then you write what the strength is. If it is closer to 1, the strength is strong, as it is in this case. So we can write it is negatively strong correlation. So that's the first thing. The next thing you have to write down the thing in context, as inversely proportional happens, you know how it works. So you have to mention older people will have lower volume of blood pumped to the heart. So older people have lower volume of blood pumped, and they mentioned by each contraction of the heart. So that's what it is. The next question deals with regression. This is one question where the correlation and regression sum is given in the same question. So let's continue. The researcher believes that a linear regression model is basically an equation where we have two variables, one x and y, and we find the direct relationship between them, may be appropriate to describe these data. So state, giving a reason, whether or not your value of correlation coefficient supports the researcher's belief. Now you have to remember there is a strong correlation. That means it supports. And you have to write this down in context. So in context, it would be, yes, it is a strong correlation. Remember, regardless of positive or negative, the value itself, whether it is closer to 1 or -1, that tells us whether it's a strong correlation. So it is a strong correlation. So whether or not your value of correlation supports the researcher's beliefs. So yes, or so it supports the researcher's belief. The next question is, we have to find the actual regression equation, and there are some rules for that. The equation itself is y equals to a plus bx. Now we have to find the value of b first. So b equals to sum of xy divided by sum of x. We don't need the value of sum of y for here. So sum of xy we already know is 710, and sum of x, that is also given, it is 2587.5. So the value of b turns out to be minus 710 divided by 2587.5, and it is minus 0.2744. Now we have to find the value of a. The value of a is summation of y by n minus b summation of x by n. Now summation of y by n can also be written as y bar. Summation of x by n can also be written as x bar. There's another way of writing it down. So we know summation of y is 560, and there are 8 data, and the value of b is minus 0.2744, and if you multiply this, x is summation of x 370 divided by 8. That's the number of data we have. So let's calculate this, and this turns out to be, first of all, 0.2744 multiplied by 370 divided by 8, and since minus and minus plus, we can just add 560 by 8, and value is 82.691. So let's write down the equation. The equation would be y equals to, a is 82.691 minus 0.2744x. That is the value of the equation, regression equation. They didn't tell us to write down the answer in a particular format, 3 significant figure or 1 decimal places. So it is all right how we write the equation. Now in F1 we have to use the equation. Jack is 40-year-old, so we know the age of Jack, so x equals to 40. Now use a regression line to estimate the volume of the blood pump by each contraction of Jack's heart. So we know y equals to 82.691 minus 0.2744 into, instead of x we write 40. So let's see what's the value of y. So we can have 82.691 minus 0.2744 multiplied by 40, and it turns out to be 71.7. So now we have to give some context as we write down the answer. 71.7 ml of blood is pumped by each contraction of Jack's heart. In number 2 we have to comment and we have to give a reason. Now remember, in order for the regression line to work, we have to take a look at the data set. If 71.7 is inside the data set, so it is reliable. If it is not, then it is not reliable. So let's take a look over here. We have 74, we have 77, we have 72, we have 76. So 71 is close to the values of the volume of blood that we have in this table. So it is reliable. So we can write, yes, it is reliable since it is inside the range of dataset.